This is an Edexcel GCSE Physics Paper 1 talk through from June 21. This question is about ultrasound. Which of these is a frequency of ultrasound? You're looking for above 20,000 hertz or above 20 kilohertz. So if you look down here, these are too low. The answer here is D. Ultrasound has many uses. One device called a pet repeller emits ultrasound. I said pet, I meant pest. The ultrasound keeps mice out of the garden. Explain why the device affects mice but does not affect humans. Okay, it's to do with the frequency of that ultrasound. So it would be within the mouse's hearing range but not in the human hearing range. So basically it would drive the mouse mad but not the human. A technician has a different ultrasound device. This device can emit and detect short pulses of ultrasound. The device can also measure the time in ms from emitting a pulse to detecting the same pulse. Describe how the technician can use this device to determine the speed of ultrasound in s. So in order to find speed, you want to use the equation speed equals distance divided by time. You want to measure the distance to the wall and back again, which means you actually want to do 2 times the distance and then the time it takes to detect that echo. Figure 1 shows parts of a wave. Use data from Figure 1 to calculate the wavelength of the wave. Remember, the wavelength is the distance between 2 consecutive parts of the wave. So effectively you could do from here to here, that would be half a wavelength. And so therefore we need to measure that. You can see that that is 14 centimetres, so we need to double it to find the wavelength to get 28 centimetres. B, part 1. Figure 2 shows a student sitting on the shore of a lake watching ripples on the surface of the water moving past a toy boat. The student has a stopwatch. Describe how the student could determine the frequency of the ripples on the lake. So remember, frequency is the number of waves per second. And it's given by the equation number of waves divided by time, or time period. So in that case, the student could count the number of waves passing a point in a specific time frame. A second would be obviously too short a time frame for the student, so maybe something like a minute. The speed of a water wave is 1.5 meters per second. The frequency is 0.7 hertz. Calculate the wavelength. Well, this is nice. They've given us the equation. So V is 1.5, frequency is 0.7. We're looking for the wavelength. So divide both sides by 0.7 to get 2.1 meters to 2 significant figures. Water waves are transverse waves. Describe the difference between transverse waves and longitudinal waves. So use this scaffolding. Transverse waves, vibrations occur, and the key word here is perpendicular or at right angles. To the direction in which the wave is travelling. Longitudinal waves, we're going to use that scaffold, but the only thing is we're going to change at right angles to parallel. This question is about radioactivity. Alpha, beta, and gamma are 3 types of radioactive emissions. Which statement describes all of these radioactive emissions? Okay, remember, first of all, they're emitted from unstable nuclei, so we're looking not at A or C. And they are ionizing radiation, so they do cause other substances to become ions, so the answer here is B. Fluorine-19 is a stable isotope of the element fluorine. The element fluorine also has several radioactive isotopes. Describe one similarity and one difference between the number of particles in one nucleus of fluorine-19 and one nucleus of a radioactive isotope of fluorine. It's a very long-winded way of asking you to define an isotope, which, remember, comes up an awful lot in chemistry. So they have the same number of protons, because remember that dictates the element. In this case, it's fluorine. But a different number of neutrons, which, remember, gives them a different mass number. Figure 13 shows a Geiger-Müller tube attached to a counter. The Geiger-Müller tube is used to measure the activity of a source of beta radiation. There's an aluminium sheet between the beta source and the GM tube. The counter is switched on, and after 1 minute shows a count of 268. The aluminium sheet is taken away, the counter is reset to 0 and then switched on again. A new count rate is taken for 1 minute. Explain why the new count rate is greater than 268. Well, remember, beta can't penetrate aluminium sheet, so when it was there previously, the reading would have been much lower. However, once it's taken away, more beta particles can reach the Geiger-Müller tube. So this is all about understanding the penetrating powers of alpha, beta, and gamma. The beta source is then taken away, the counter is reset to 0 and switched on again. A new count is taken for 1 minute. Give a reason why there would now be a reading on the counter: because of the presence of background radiation. State the SI unit for the activity of a radioactive source. This is the Becquerel, BQ. You can write it out in full or like this. Radium-223 is a radioactive substance. Radium-223 is an alpha emitter. The half-life is 11 days. A radioactive source contains 1.7 times 10 to the 23 nuclei. Calculate the number of radium-223 nuclei remaining in the source after a time of 33 days. So first of all, we need to work out how many half-lives must have taken place in 33 days. We know each half-life takes 11 days. So this is the equivalent of 3 half-lives, which means we take that activity of that radioactive source and halve it 3 times. Once you've done that, you get an answer of 2.1 times 10 to the 22 to 2 significant figures. The Big Bang Theory is one theory for the origin of the universe. The Big Bang Theory suggests that the universe had a beginning. The universe is still expanding. Which of these provides evidence that the universe had a beginning? It's actually D, CMBR, because they believe that CMBR was made at the inception of the universe, and then with that Big Bang, it forced that CMBR to be evenly distributed throughout the universe. Evidence that the universe is still expanding comes from observations of light from distant galaxies. Describe how light from distant galaxies shows that the universe is still expanding. So this is all about redshift. Because light from distant galaxies appears more red, that is light with a longer wavelength, which means they must be moving away from us. And therefore the universe is still expanding. The steady state theory is also a theory about the origin of the universe. Give one similarity and one difference when comparing the Big Bang theory with the steady state theory. Okay, a similarity is that they both include the concept of an expanding universe. But in the steady state theory, the universe had no beginning. Observations of the expanding universe have shown that the further away a galaxy is from the Earth, the faster the galaxy is moving away. Figure 4 shows how the velocity of galaxies is related to their distance from the Earth. MPC is a unit of distance used for large distances in space. Use figure 4 to estimate the velocity of a galaxy that is 15 MPC away from the Earth. So let's draw a line up from 15 MPC and then read across, and that is around 1050. Calculate the gradient of the line shown in figure 4, state the unit. Let's get this out of the way so it's less confusing. Okay, let's form a triangle. I'm always looking for the place where it makes most sense for me to draw the line. Okay, here's my triangle. Here's my change in y, here's my change in x. My change in y is 1,400 minus 250 divided by my x value, which is, just read this carefully, that's around 3, it goes up to 20, so that's 17. So you will get a slightly different answer here, and my answer is, I need to move my answer down. My answer is 67.6, and then my units are, well, my y value was kilometers per second, and I divide that by the unit for distance. So it looks like this. The gradient of the line in figure 4 can be used to estimate the age of the universe. Explain why the gradient of the line in figure 4 can only provide an estimate for the age of the universe. We'll have a look. The points are extremely widely scattered, which means that that line of best fit could effectively be in so many other places, and therefore, once you calculate the gradient, that value could change drastically. A student is investigating the refraction of light. Figure 5 shows part of the apparatus and the angles to be measured. The student measures angle R for several different values of angle I. On the graph in figure 6, draw the best fit curve. Use the graph in figure 6 to estimate the value of angle R when the angle is 80 degrees for the angle of incidence. So here's our angle of incidence being 80 degrees. And then read across that y-axis to get around 42 degrees. Describe how angle R changes with angle I for the results shown on the graph in figure 6. So you can see that as the value of I increases, the angle R value increases, but it's not directly proportional at all because we've got a non-straight line. And in fact, you can see that as the I values get greater, the R values become less. In figure 5, the frequency of the light remains the same in glass as in air. Which row of the table describe what happens to the wave velocity and to the wavelength of the light when the light travels from air to glass? So it's going to slow down. So if the wave velocity decreases, what's going to happen to the wavelength? Remember, the waves get closer together when they slow down. So that's why the answer here is A. In figure 7, only refraction of light is shown. Other things happen to the light as it travels from P to Q. The intensity, brightness of the light at Q is less than the intensity of the light at P. Explain the decreased intensity as the light travels from P to Q. You may add to figure 7 to help your answer. So what you actually find is up here, some of the light is reflected. We can label that here. And also some of the light is absorbed by the glass, both of which will reduce its intensity as the light travels from P to Q. Which of these sketch graphs represents the speed of light as it travels from P to Q? So in this portion it will be travelling fast inside the air, here and here, and then it slows down in the mid portion as it enters the glass block. So there we are in air, travelling fast, and there it is slowing down. But notice it will travel at the same speed in air, so that's why this is correct. Which of these graphs represents an object moving with a constant velocity of 2 meters per second? Velocity is given by displacement over time. So we can do that for the first graph here. Let's work out its gradient. So it becomes 2 divided by 5, which is 0.4. So that's why that's not the answer, because it's not 2. What about option B? The question asks us about constant velocity, whereas here we have a constant acceleration, because look, our y value's changed. It's turned into velocity rather than displacement, and acceleration is change in velocity over time. So that's not what's happening here. So that's why B can't be correct. And if you actually check the y-axis label here, that's also talking about acceleration. Let's check YC is correct. So velocity is displacement over time. So let's look at this point here. 10 divided by 5 is 2, which is matching our answer that we need. So the answer there is C. Figure 8 is a velocity time graph showing a 34-second part of a journey. Calculate the acceleration of the train in the 34 seconds. Give your answer to an appropriate number of significant figures. So acceleration is change in velocity over time. So let's check what that change in velocity is. So there's our final velocity, 26, so that's V. Our initial velocity is 14. We know that our time frame is 34. Do 26 minus 14 divided by 34. And then we have 2 significant figures everywhere else. So I'm going to go for 2 as my final answer. Then we're being asked to calculate the distance the train travels in the 34 seconds. So we're after S. Let's use V squared equals U squared plus 2AS. We'll list our values. Our final velocity was 26. Our initial one was 14. Our acceleration we just calculated is 0.35. We're looking for that distance S. So substitute in your values. Line up your answers nicely. So first of all, do 26 squared, 676. 14 squared is 196. 2 lots of 0.35 is 0.7. Take 196 away from both sides to get 480. And then divide both sides by 0.7 to find S. So to one decimal place, our answer is 685.7. Figure 9 shows a rocket soon after it takes off from the ground. The force that the rocket engines produce remains constant during the first few seconds after takeoff. Explain what happens to acceleration during the first few seconds. So we've been told that the force remains constant. We're being asked about acceleration. Hopefully you know that you need this equation, which is force equals mass times acceleration. So if the force stays constant, we know that as it takes off, the mass decreases. Why? Because fuel is being burnt off. And so therefore, to make it true that the forces remain constant, acceleration, or the value of acceleration, must have increased. Always use equations to back up your answer. Figure 10 shows a small steel ball held at height h above the ground. The ball is released and allowed to fall to the ground. The height h is 1.4 meters. Calculate the time for the ball to reach the ground. Use this equation. Substitute in 1.4 is your height. Gravity, we're told, is 10. So it becomes 2.8 divided by 10, 0.28. And then square root your answer. So the answer is 0.529, 0.53. Two students use the arrangement shown in figure 10. They use a stopwatch to time the ball falling through a height of 1.4 meters. The students repeat the measurement many times, but the average value for t is different from the calculated value. Suggest a reason why the student's value for t is different from the calculated value. Well, it's really because the student's reaction time is quite significant if you compare it with the recorded time value. Suggest one improvement that students could make to their procedures so that their value for t is closer to the calculated value. I would use light gates. Figure 11a shows a box falling towards a hard floor. The box hits the floor and crumples a little before it comes to rest. The momentum of the box just before it hits the floor is this. The box comes to rest in 0.35 seconds after it first hits the floor. Calculate the magnitude of the force exerted by the floor on the box. Use an equation selected from the list of equations at the end of this paper. So you want force equals change in momentum over time so that change in momentum we've been told is 8.7. The time value is 0.35. So our answer here is 25 newtons. State the magnitude and the direction of the force exerted by the box on the floor. It will be acting downwards. Hopefully you realise that it's acting downwards towards the floor. And the magnitude of that force will be equal and opposite. So it's also that value you just calculated of 25 newtons. Figure 12 shows a ball held in a clamp at R above the ground. The ball is released from the clamp and falls. S is 3.8 meters below R. At S, the momentum of the ball is 0.4. Calculate the mass of the ball, and the acceleration due to gravity is this value. So this calculation has two stages. We definitely need to use the equation that states momentum is mass times velocity, because we have the momentum, which is 0.4. We're after the mass, but unfortunately we don't have the velocity. However, we can use v squared equals u squared plus 2as to help us find that all-important velocity, which would be v squared in this case. U squared, we know that the ball is released from being still, so that's 0. The acceleration due to gravity, we've been told, is 10, and the distance is 3.8. So sort out that right-hand side to get v squared equals 76, meaning that v must be 8.717. And now we can pop that up here to find the value of x. Divide both sides by 8.717. So the mass of the ball is actually 0.046, to two significant figures. So this is a place where using two equations is very important, because we didn't have enough information to go straight to this equation, but once we use this, we found that all-important missing velocity that enabled us to calculate the mass. The asteroid belt is part of the solar system. Vesta is an asteroid in the asteroid belt. Vesta orbits the Sun between the orbits of... Okay, where is the asteroid belt? Well, it sits between Mars and Jupiter. Vesta has an orbital speed of 1.9 times 10 to the 4. Vesta travels a distance of 2.2 times 10 to the 12 meters when it orbits the Sun once. Calculate the time taken for Vesta to orbit the Sun once. So time is distance divided by speed. So the distance is 2.2 times 10 to the 12. Speed was 1.9 times 10 to the 4. So our value here is 1.2 times 10 to the 8. Explain why Vesta is accelerating even when it's travelling at a constant speed. So acceleration is a vector quantity, which means it has both a direction and a magnitude. And if you think about it, although its speed, that magnitude remains constant, it's constantly changing direction. So that explains why it's accelerating. Energy is transferred from the Sun to Vesta by radiation. Explain why the temperature on Vesta does not continue to rise even though it is absorbing energy from the Sun. That's because Vesta is also radiating energy, and it's going to be radiating at the same amount of energy that it absorbs, and crucially this occurs in the same time period. The distance between Vesta and the Sun is 2.4 AU. 1 AU is the distance between the Earth and the Sun. The intensity of the Sun's radiation reaching the Earth is 1,400 watts per meter squared. 1 watt is 1 joule per second. The intensity of the Sun's radiation at distance d from the Sun is given by this equation, where k always has the same value. State the unit of k. Let's rearrange that equation so we can see that it is k equals intensity times d squared. So we know the intensity is given by W per meter squared, which actually looks like that. Then we know that the distance is in meters squared. So actually these two values cancel out, leaving a k unit of watts. Calculate the intensity of the radiation from the Sun at Vesta. Let's steal this equation. Because first of all, they've told us that the value of k is always the same. Let's work it out first of all. Because if we know the intensity of the Sun's radiation reaching the Earth is 1,400, we can put that there. We're looking for k. The distance we've been told is 1 AU. So 1 squared is 1, so k equals 1,400. And then what about d squared? That distance from Vesta to the Sun is 2.4. Our intensity is 243 to two significant figures, 240. Sometimes food can become contaminated with radioactive substances. Describe the harmful effects. So that radioactive substance gets taken inside the body, and then because it's radioactive, it emits ionizing radiation, which can lead to the mutation of cells and potentially cancer. So not something that I would recommend. So eating or ingesting food containing radioactive substances may mutate cells and lead to cancer. due to the ionizing radiation given off. Gamma radiation can be used in food processing to irradiate food. Explain why some food is irradiated with gamma radiation. Because gamma radiation kills bacteria and therefore acts as a sterilizing agent. Gamma radiation is part of the electromagnetic spectrum. When the nucleus of an atom emits a gamma ray, the number of protons in the nucleus and the number of neutrons in the nucleus do not change. State how the nucleus does change when it emits a gamma radiation. It actually becomes more stable as that energy is emitted. Gamma radiation is produced by radioactive decay. Alpha radiation and beta radiation are also produced by radioactive decay. Compare the processes of alpha and beta decay. Your answer should include what each radiation is and what effect each decay has on the original nucleus. So let's start by saying what alpha radiation is. Remember, it's a helium nucleus made up of 2 protons and 2 neutrons. So what effect does each decay have on the original nucleus? The original atom's mass number decreases by 4. Whilst the atomic number, which is to do with the proton number, decreases by 2. So that's enough for alpha radiation. What about beta radiation? Beta radiation is actually a fast-moving electron. Which is negatively charged. What happens to the atom? The original atom mass number stays the same, whilst the atomic number increases by 1. Figure 13 shows wind turbines used to generate electricity for the national grid. The wind turns the turbine blades. The wind is a renewable source of energy. State 2 other renewable sources of energy. Lots of options here: tidal, geothermal, biomass, solar. For one turbine, the energy input per second from the wind is 6.2 kilojoules. The energy output per second is 2.2 kJ. Calculate the efficiency. So the efficiency is given by useful energy output over total energy input. So our useful energy out is 2.2 kJ. The energy input is 6.2. So our efficiency is 0.35. You could have also multiplied that answer by 100 to get 35% if you prefer. Suggest a reason why it is impossible for the turbine to use all the kinetic energy of the wind. That's because not all of the air hits the blade, and there's also friction within the turbine or the generator, or some energy is always wasted as thermal. So yeah, lots of options here. Nuclear fission and nuclear fusion are 2 non-renewable sources of energy. Compare nuclear fission and nuclear fusion as possible source of energy for generating electricity using a nuclear reactor. Your comparison should refer to the differences between them and the relative advantages and difficulties involved in using these. So let's start by saying what they both are. So nuclear fission is when the nucleus is split due to the absorption of a neutron. What do you produce? Well, two smaller daughter nuclei, as well as 2 to 3 neutrons, which go off and hit other uranium nuclei. And then this starts a chain reaction. Nuclear fusion is when two light nuclei are joined. There's a release of energy and a loss of mass. So we've talked about the differences. What about the advantages and disadvantages? Advantages of fission. Already used technology, so we know it works. What about the disadvantages? We know that the waste is radioactive and there's risks of accidents such as what happened in Chernobyl. What about the advantages and disadvantages of fusion? So the main advantages are that there's no harmful waste products. However, the main issue is that, and the main disadvantage is that we haven't really achieved it yet because the high temperatures needed to overcome the repulsion forces of those positive nuclei have not been achieved yet. So if I scroll back out, I know that I've done both parts of the question.